Then, NASA announced that the Voyager 1 spacecraft, the most distant object created by humans, had once again transmitted valuable information back to Earth. Located nearly 24 billion kilometers from our planet, this ancient spacecraft broke a long silence. It was launched 4.5 decades ago and has been functioning for almost 35 years, far exceeding its originally planned lifespan. This was not just a stream of data or noise. It was something special, fragmented, persistent, almost unbelievable signals. Voyager crossed a region of space that no one could comprehend, and what it discovered completely changed our understanding of the universe. In 1977, 2 spacecraft were launched from Cape Canaveral as part of a mission designed to last 5 years. They were named Voyager 1 and Voyager 2. Both probes were similar in design, but took different routes through the solar system. They were built with computing power less than that of a modern calculator and had no plans for long-term existence. Their task was simply to take pictures of the gas giants, transmit a few photographs, and then fall silent forever. Voyager 1 was launched second, but due to a faster trajectory, it surpassed its sibling. It utilized a rare planetary alignment, a gravitational maneuver that occurs only once every 176 years. This chain reaction of gravitational pulls allowed it to race past Jupiter and Saturn at an incredible speed, significantly exceeding what it was designed for. It had no backup processors, artificial intelligence, or solar panels. The only source of power was a nuclear battery that slowly decayed over the decades. Its memory was a mere 69 kilobytes. Nevertheless, year after year, it continued to function. It captured volcanic eruptions on Io, revealed the thick orange haze of Titan, and showcased the intricate rings of Saturn and the magnetic fields of Jupiter. But after the primary mission was completed, when everyone expected its end, Voyager did not cease to exist. It continued its journey without maintenance or upgrades, representing only a fragile metal shell that drifted farther than any other human-made object in history. As it crossed the boundaries of the planets and delved into the dark expanses, it entered a realm where no spacecraft had ventured before. That was when the true mission began, opening new horizons in our understanding of the solar system. Long before it reached the edge of the solar system, Voyager changed our perception of what it represents. Its first target was Jupiter. Scientists expected to see a giant gas planet, and what Voyager revealed was a true colossus, filled with intense radiation, powerful storms, and complex magnetic fields. But the real shock came from one of its moons. Io turned out to be not a dead rock, but a living world. Volcanoes erupted from its surface with astonishing force, ejecting molten material hundreds of kilometers into space. This was the first observation of a volcanic eruption beyond Earth in history. Then it was Saturn's turn. Voyager revealed the true nature of its iconic rings, which were found to be intertwined, wavy, and shaped by tiny invisible moons. It captured unexpected gaps and strange patterns, as well as dynamic interactions that made Saturn much more mysterious than scientists had anticipated. However, the most impressive discovery was Titan. Shrouded in an orange atmospheric haze, it displayed signs of organic chemistry. Its thick, nitrogen-rich atmosphere felt eerily familiar, possibly reminiscent of early Earth. Voyager could not penetrate the clouds, but what it hinted at changed our understanding of planetary evolution. Voyager 2 continued its journey, and in the year 1986, it reached Uranus, becoming the only mission to ever fly past this planet. Here, it discovered a planet lying on its side, with a magnetic field that was completely misaligned with its rotation. Then, in the year 1989, Voyager reached Neptune, where it recorded supersonic winds and a dynamic atmosphere far more violent than could be imagined. Neptune's moons, such as Triton, were erupting nitrogen geysers into space that froze before they fell back down. The surface of Neptune appeared young, possibly shaped by internal forces. These were not just interesting facts, they were true revelations. Voyager showed the solar system as living, dynamic worlds, with atmospheric moons and storms exceeding those on Earth, as well as magnetic fields that did not conform to known theories. The more it discovered, the more it reminded us that the cosmos is not a void, but a space full of surprises. Yet even the most distant planets remained part of our home. When Voyager flew past Neptune, there were no new worlds left to explore. There were no moons to photograph, only silence ahead. And in that silence, the solar system itself began to unravel. Into the void, to the edge of it all. Left alone, Voyager entered a region where no spacecraft had ventured before. This was the boundary between our solar system and everything beyond it. But this boundary was not linear. It was a true battleground. The solar system is surrounded by a gigantic invisible bubble called the heliosphere, formed by the solar wind, a constant stream of charged particles emanating from the sun. For billions of kilometers, this wind pushes outward, creating a protective cocoon. However, it soon encounters resistance from the interstellar medium, a sparse gas, dust, and radiation filling the galaxy. It is precisely where these two forces collide that the heliopause is located, the true boundary of our solar system. For years, scientists did not know what to expect. Would Voyager break through the wall? Would the transition be smooth? Many theories were proposed, but in the year 2012, the signals changed. The particle detector on Voyager 1 recorded the disappearance of solar particles. The magnetic fields shifted, and external forces began to exert stronger pressure. Then, there was a sharp increase in plasma density. Voyager crossed the heliopause and became the first man-made object to enter interstellar space. In the year 2018, Voyager 2 followed. However, strangely, it did not record similar data. Voyager 1 encountered dense clusters of interstellar plasma, as if facing invisible walls of pressure. Meanwhile, Voyager 2 detected something entirely different, a flow of elongated particles moving in unexpected directions. The same boundary, but two different experiences. Even more concerning was that both spacecraft recorded what lay beyond. The heliopause turned out to be not smooth, but wrinkled. Enormous magnetic folds, formed by solar flares, stretched for billions of kilometers into space. They were not static, but constantly moved and changed. In some places, it seemed they were following the spacecraft. Models collapsed, predictions failed. The edge of the solar system, which once seemed quiet and calm, turned out to be chaotic, turbulent, and loud. Voyager did not find peace in the outer darkness. It encountered noise, pressure, and constant movement. This edge was not an end, but merely a beginning. A failure that was supposed to conclude everything. At the end of the year 2023, decades after Voyager 1 entered interstellar space, something went wrong. The signals it sent became distorted. Fragmented pieces, disjointed bits of data that made no sense. Telemetry disappeared. No readable information. This was an unusual failure, but the spacecraft continued to function, still transmitting. However, what it reported was incomprehensible. Initially, engineers assumed it was a temporary disruption. Perhaps cosmic rays had damaged the data during transmission. But diagnostics revealed a more serious problem. A damaged section in the flight data processing subsystem. A fragile memory block responsible for organizing all information before sending. One single chip, likely affected by radiation, disrupted several critically important bits. This was not just a failure, but a breakdown at the very core of the spacecraft's memory. In that part of the system, which had not been touched since the 1970s. There were no spare parts. Tools for repair were absent, and the engineers who designed this system, many of whom are now retired or have passed away. Nevertheless, at the Jet Propulsion Laboratory at NASA, a small group of mission veterans and young engineers refused to give up. They studied old documentation, found schematics for equipment that was 40 years old, and began to restore the system. Line by line, byte by byte. The corrections needed to be sent over 24 billion kilometers. The signal took more than 22 hours to travel one way, and if they made even one mistake, the spacecraft could be lost to darkness forever. In April of 2024, they transmitted a data packet and waited. The response came a few days later. The signal was clear, the data intact. Voyager 1 had been restored, remotely reprogrammed from the depths of space by a team that refused to let it perish. It was not designed for repairs, but it was fixed. This became a message to the unknown. Long before Voyager left the solar system, before it passed the storms of Jupiter or the rings of Saturn, engineers attached a golden disk to its body. This message was not addressed to us, but to them. It was called the Golden Record, a copper disk 12 inches in diameter, coated in gold, sealed in an aluminum case, and affixed to the spacecraft. The record contained greetings in 55 languages, sounds of a heartbeat, wind, thunder, and music from various cultures. Bach, Blind Willie Johnson, and songs of the Navajo people. It also included diagrams of human anatomy, DNA, and directions to locate Earth in the galaxy, marked using pulsars as reference points. To expect that anyone would ever find this record was unlikely. The chances that any civilization would intercept a spacecraft from the 70s wandering through the vastness were practically zero. But that was not the point. This was a vision of Carl Sagan, an act of cosmic humility, a statement that somewhere in a brief moment of time, a species existed that could not only observe the stars, but also wished for the stars to know of its existence. The instructions engraved on the disk explained how to play it, provided that whoever listened could read the language of physics. Even the medium itself, made of gold, was a symbol, durable and timeless. This was not a radio transmission, but a whisper. And even if no one ever hears it, it still speaks of what mattered most, drifting in eternity. Today, both Voyager spacecraft are still out there, quiet and steady, moving away from Earth with every passing second. Voyager 1 is now more than 24 billion kilometers from home, the most distant object ever created by humankind. Voyager 2 trails slightly behind, continuing its endless journey into the void. Their instruments are gradually beginning to fade, energy from the nuclear batteries decreasing each year. To conserve it, NASA is shutting down systems one by one. By the middle of the year 2030, the Voyagers will fall silent. There will be no more measurements of plasma, no more data on magnetic fields, only cold metal drifting in space. But silence is not the end. Even devoid of energy, the Voyagers will continue their journey onward, invisible and untouched. They will fly for tens of thousands of years, long after the Earth has changed, long after the last signal has disappeared. They will still carry their golden disks, echoes of our existence, spinning in the darkness like ancient relics. And yet they continue to teach us. Every change in their readings, temperature, density, pressure, tells us something new about the space between the stars. The plasma instrument on Voyager 2 is still recording important data, while the magnetic sensor on Voyager 1 continues to detect faint waves of charged particles passing through the galaxy. Even 48 years after their launch, they are still rewriting what we thought was true. They are no longer just missions. They have become monuments. They were never built for navigation, but they have found eternity. Drifting through the darkness, beyond memory and maps, the Voyager still carries us. This is not just a signal waiting for a response, but a quiet testament that we reached out to the stars and left something important behind.